Hi, welcome back to our series on Internet of Things with the Raspberry Pi. I am Jason Vasalio, and for this experiment, we will be using the Raspberry Pi for a home automation application with the Node MCU, the Node microcontroller unit using the ESP8266. Alright, so the first thing that we'd want to do is to go to our terminal. In my case, as you can see, I already have this code prepared for this application. Now, let me go to the terminal that you have here and type in sshpi at raspberrypi.local. This is where our Raspberry Pi is located. Alright. Okay. Now let me just put this here and type in, I guess, node red start. This is to start our node red server in our network. Alright, so let's just wait for that. Alright, so now we have the server now running at this address, but we will be going to this address. Alright. So to go to that address, let's just type in 192.168.100 or .0.10110 and then colon 1880. Alright, press enter. Alright, so as you can see, we have here our nodes, but let's delete them and start from the beginning. Alright, so the first thing that we'd want to do in this application is to create a node for the dashboard. In my case, we will be applying this to the fan right here as well as the light right here. Okay. So to do that, I'll be using the switch, and I will be creating, or I will be assigning this to the home automation appliances and label this as light switch. Okay, so we will change the payload to instead of true, turn on lights. This will be for our MQTT application. MQTT is a communication protocol that can be used either within your network or in the web, outside in the web or cloud. And this will allow you to control everything that you have in your smartphone. Turn this to turn off lights. Okay. Now after that, we will also be using the fan. So let's name this as fan switch. And change the payload to string. Turn on fan as well as the turn off fan. Okay. So if you will notice, you will see that the payload was changed to string in both of the switches instead of a Boolean variable of true or false. Now this is because in our program for the NodeMCU right here, which is connected to or will be connected to our Wi-Fi, we assigned the message to be turn on lights under the topic home/appliances. Okay, so with that in mind, let's now go to our MQTT node, which will be the MQTT out. Alright. Now we will change the MQTT topic or set the MQTT topic to home/appliances with a quality of service of 2 and name this lights. Alright. We will do the same here. Home appliances. Quality of service 2 and name this as fan. Alright. Now, after this, let's go ahead first to our VS Code and upload this to our microcontroller unit. Let's just hit upload. Right. Right. So now that we have completely uploaded the program to the NodeMCU or the Node microcontroller unit using the ESP8266 with Wi-Fi enabled, let's now go ahead to our serial monitor and press on the reset button on our board. Now this will be connecting our board to our network, which was already done previously. So right here, as you can see, it has automatically connected successfully. So if we go ahead to our command prompt right here and change our directory to the C, and then to our program files, and then onto our Mosquito folder, we will be placed right here in our directory, which is where we will be able to control our Mosquito publishing or subscribing, stuff like that. All right, so hold on. Let's place this. Let's just place this right here. All right. So right here on the left hand side of the terminal, we have the serial monitor of the NodeMCU, and on my right is the command prompt or the terminal that we have in Windows. So let me type mosquito host dash h, where our host is on 192.168.0.110, and our port name or our port at 1883 for our MQTT port right here indicated 1883, and publish, or under the topic, home appliances, and then publish a message of maybe turn on lights. Alright, so it seems that we have forgotten to put underscore pub for publish. Okay, so as you can see, as soon as I entered this command, the LED in our NodeMCU turned on, and now it's indicated right here in our NodeMCU serial monitor, which is printed. Okay, so let me try that one more time, but with the fan. Alright, so as you can see, as soon as I pressed the or entered the command, the fan started to work. Now let me turn them off. Turn off. Turn off fan, and then turn off lights. Alright, so you get the idea of the MQTT, that it publishes messages in our network, and whoever is listening or subscribed to that topic where the publisher has published, where a client has published something, then every device that is listening to that topic will be affected. Now, the same here in our NodeMCU. As you can see, we have the topic as home appliances at the port 1883 with the host at 192.168.0.110. Same is for our fan. Now if we hit on deploy and go to that address or the UI address, which is the host name and the 1880 port slash UI, we will see this dashboard or this user interface. Alright, so if I click on this fan switch, as you can see, as soon as I clicked it, the fan turned on. The same should be seen right here in our light switch. Alright. So, as you can see, our NodeMCU is not physically connected to our Raspberry Pi. The Raspberry Pi accesses the NodeMCU through our network using the MQTT communication protocol. Now, let me now try accessing everything using our smartphone. Right. So let me just type in here 192.168.0.110 colon 1880 slash UI. So as you can see, still we are prompted with our dashboard. Now, so as you can see right here in my phone, as soon as I click the fan switch, the fan should turn on, and same should go with the light switch. Now let me do that. So as you can see, the light switch is working properly. Same as the fan switch. So let's see the applications of this type of project. So as you can see, the NodeMCU is being accessed remotely or is being controlled through the MQTT. And as we know, as we know that this Raspberry Pi is not that cheap. It's very expensive. It costs around 4,000 pesos. So if we put Raspberry Pi on each device, each appliances, it will be costly. Now, this NodeMCU costs just around 100 pesos or 150 pesos. And this type of application is very fit for a home automation kind of application, where if we put this NodeMCU in each of the appliances or nearby appliances will also be controlled if you want to plan it that way, then it will be cost effective as well as it being very useful for the home application. All right, so that will be it for our experiment. See you on the next one.